About exponential functions.
Go with exponential.
And we're talking about exponential. That's where you take an EpiPen and you repeatedly stab yourself with it. Exponential growth.
Speaking of poisoning people.
Exponential functions. Okay?
So just like the E thing and the...
We're getting to the E thing. We are getting to the E thing.
Like one of the only things I
Are we done with the I thing?
For a little while. We'll come back to I later.
Okay, so we're doing logarithms now?
Any day now. Okay. Exponential, or maybe early next week.
Wait, when are we going to stop reviewing?
Honestly, like December or January. But it's gonna get. But each review things go a little deeper. I know.
Wait, then why are we reviewing?
Oh my God, be quiet. Okay, exponential functions. I started a little late, so I'm in a bit of a hurry now. Exponential functions. To understand exponential functions, you've got to get exponential behavior. If you guys remember the example I used, the ultimate example of exponential behavior we talked about last year was the guy who invented chess, or the legend of the guy who invented chess. Bobby Fischer was a chess master. He did not invent it.
Chessmaster 2000.
No, it was not invented by a computer.
Scrabble. When did
You guys grasp what cause and effect is horrifying.
Sorry.
Okay,
Person.
quick test. Alexander, what were the first words spoken into a telephone?
Somebody come over here.
Watson, I need you.
Watson, I need you. Can you hear me now? That's good. Most Americans actually, when polled, said what were the first words spoken in a telephone, said the first words spoken into a telephone ever were hello. Think about that for a minute. For that to happen, it would have had to have been like he built it, he invented the first one, and then it rang. That makes no sense. So yeah, first was Watson, come here, I need you.
He would probably have dropped dead from shock.
But no, chess was invented in ancient Persia. And chess was fantastic when it was built in ancient Persia because there was no Nintendo, there was no internet, there was no Comcast on demand. It was like a new way to pass the time.
He told us the story with each square with different
Grain of rice. Yes. Okay, so
oh, now I remember.
Yeah, the guy who invented chess was told by the king, "You've done such a great service. We have some new way to spend time that I will give you any reward you ask for that I can." And he said, "Okay, I would like you."
10,000 version.
No. He said, all I want, and this guy was brave to say this to the king. He said, all I want is take one of my chessboards, and I want, which is 8 squares by 8 squares, and I want a grain of rice placed on the first square. And then I want 2 grains on the second square, 4 on the next, 8 on the next, 32 on the next, etc. Yeah, and so on. I want that to keep, and the king said, sure, that sounds like a reasonable request. That's not, how much rice could that possibly be?
A lot.
Well, that means on the...
It's 64.
Well, in the first square, he asked for 1 grain of rice, which is 2 to the 0 power. On the second square, he asked for 2 grains, which is 2 to the first. Third square,
2 to the 64.
2 to the second. Fourth square, 2 to the third. There's 64 squares on a checkboard. So since so far the exponent has been 1 less.
Checkers with chess. Chessboard.
That's true, chessboard. So there will be 2 to the 63rd power. Somebody take out your calculator and tell me what raised 2 to the 63rd power.
9.22372037E18.
Yeah.
9.22 E is times 10 to the what?
So 922-337-203-6854.
Okay, let's start at 922.
Hold on.
Okay.
That's... Oh, no, that's not bigger than that.
Wait, E to the 18 means 10 to the 18?
Yeah, E to the 18th on your calculator means times 10 to the 18th. It's how it does scientific notation.
If you had that many marbles, you'd fill up over half.
You would. So this means 922. Okay, starting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Thousands, millions, billions, trillions.
How much?
I forget. I really forget.
Quadrillion, quintillion.
Quadrillion, quintillion.
9 quintillion.
9 quintillion. There's not 9. There probably was not 9 quintillion grains of rice in the world in Persia.
Maybe if sand.
And Dean's got something here. That's just on the last square. We're going to get more into this later in the year, how you handle sums like this, but...
So you do that sigma and then the...
Yeah, use a sigma and add up. We're not going to get to that for a while. On the second to last square, there was 2 to the 62nd. What's that? So that's just going to be this cut in half. So that's going to be about 4.6 times 10 to the 18th. So it's 4.6 quintillion. On the 62nd square is going to be 2 to the 61st.
2 quintillion.
So that's going to be about 2.3 times 10 to the 18th. How am I going from here to here to here so fast?
What are you asking?
What's on the 63rd and 62nd square?
Division.
Yeah, division by what?
2.
Alright,
2. The whole point of this exponential growth is he was repeatedly multiplying by 2. So if this is on the last square, half of that must be on the square before it, and half of that must be on the square before that.
I would have loved to see the king's face after this.
After he figured it out?
What did he do?
Luckily, kings often,
Is this something else?
it's a legend, so it's probably based in fact, but
Legend's supposed to be useful.
the point is, the king had this idea, let's see, 1.65. Incidentally, my point for this one is, I'm down to, just going down to the 64th, the 63rd, the 62nd, the 61st square, I'm still in the quintillions. Okay, there's not this much rice in the world, and that's just on the last square. The point is, exponents are repeated multiplication, and they go up very, very quickly. The king supposedly was a hardy soul who simply said, ha ha ha, you tricked me, clever fellow. Which is good, because most kings in history would have been like, ha ha ha, you made me look stupid. I'm going to have you and your family killed now. Your homes burned, your crops raised, your livestock sold, and I will salt the earth where your home once was, so nothing will ever grow there again.
That's good to know.
That's how most kings. So if you're ever in the presence of a king, you don't necessarily want to mess with their heads like this.
Shoot him before you can kill him.
Good luck with that. You see how fast exponents grow? What kind of numbers you deal with? The way exponential functions. Now, the sum part, we're not going to deal with till later in the year. The idea of adding all this up.
Isn't that like factorial?
Oh, can't
No,
wait.
that's probability.
Can't wait. Okay, so we get to that. Now, for exponential functions, though, if you have y equals some number